so today we're going into section 2.6 over rational functions. So last lesson, a couple of lessons, we were looking at rational expressions, which was a quotient of two polynomial expressions. Now a rational function is a quotient of polynomial functions, so that's the difference there. We're talking about functions this time. So in this first lesson, the first part of 2.6, we're going to be talking about asymptotes. So an asymptote is an imaginary line that the function gets closer and closer to, but never touches. So it's kind of like a guide to our graph of these rational functions. So we're just laying the groundwork today, and then next lesson we'll start graphing these rational functions. So three kinds of asymptotes we're going to talk about: a vertical asymptote, a horizontal asymptote, and a slant asymptote. So in this first example, we see a vertical asymptote of x equals 0. So you could draw this like imaginary dotted line down x equals 0 there, and that you can see that these graphs are getting closer and closer as it goes up. It's getting closer and closer to this line, but it's never going to touch it. A horizontal asymptote would be right here at y equals 0, and you can see it's going to get closer and closer. It approaches it but never touches it there. Okay, and then the third one is the slant asymptote, sometimes called the oblique asymptote. So those words are interchangeable there, slant and oblique. And you could see in this example, this would be your slant asymptote here. Now these slant asymptotes follow y equals mx plus b, that line. It's a linear line there. And we're going to divide to find this slant asymptote, either using synthetic or long division, and we'll see that later in the lesson. All right, so that's basically what we're talking about today. Now let's look at how to find these moving forward. Before we can do that, we're going to quickly review finding domain. How do you find the domain of a rational function? If you think back to previous lesson when we went over this learning target, you can't have a denominator of 0. So the domain of these rational functions are going to be all the reals except for our exclusions, except for whatever would make the denominator 0. So quickly to review this, you're going to set the denominator not equal to 0. So number 1, x plus 6 cannot equal 0. And then you just solve for x. So x cannot be negative 6. So your answer would be all the reals excluding where x is negative 6. And then you can give interval notation. So that would be negative infinity to negative 6, union or and negative 6 to positive infinity. And that would be the domain there. Okay, pause the video, try the other two on your own. Let's take a look at those. So set the denominator equal to 0, not equal to 0. This one you're going to have to factor. It's a difference of squares there. So x cannot be negative 3, x cannot be positive 3. Interval notation, so all the reals except for negative 3 and 3. Negative infinity to negative 3, negative 3 to 3, and then 3 to positive infinity. All right, next one, see how you did on that. Set denominator equal to 0, go through your factoring process After your process, you would get this in factored form. And then, so all the reals, but x cannot be negative 1/2. X cannot be negative 1. And interval notation, negative infinity to negative 1, negative 1 to negative 1/2, and negative 1/2 to positive infinity. All right, so that was just a quick little review on domain there. Now we're going to go on to finding these asymptotes. So first we're going to look at vertical and horizontal. So on page 47, you're given your set of success criteria here. So this success criteria is good when the numerator and the denominator have no common factors. So to check for this, you want to factor the numerator and denominator completely and then see if anything can cross out, and then you would go from there. But if they don't have any common factors, we can follow these steps without having to do this step. So let's look at what the success criteria says. So let's talk about vertical asymptotes first. Vertical asymptotes are simply the zeros of the denominator. Zeros of the denominator. So let's look at number 4 here. I can find all vertical and horizontal asymptotes of the function. And let's find the vertical. So step 1, you need to check for common factors. So let's look at this. Can the numerator or denominator be factored? No. So we don't have to worry about that step. We can go to step 1 where it says vertical asymptotes. So those are the zeros of the denominator. So we're going to set the denominator equal to 0 and solve for x. So we would add 4 to both sides and we'd see that x equals 4. So the line x equals 4 is your vertical asymptote. So the graph is getting closer and closer to x equals 4, but not ever touching it. Okay, so that's vertical. Now let's talk about horizontal. So horizontal is a little more complicated. You have to take a few things into consideration. So the first thing you need to do is find the degrees of the numerator and the degree of the denominator. So n and m. So whatever the degree or the highest exponent of the top and whatever the highest exponent of the bottom. So this would be the degree of 1 for the numerator, degree of 1 for the denominator. So 1 equals 1. Top equals bottom. So this case, when they're equal to each other, falls under B here. When the degrees of the top and bottom are equal to each other, then the graph has the line y equals a over b as a horizontal asymptote. So y equals a over b. And let's look up here. A and b are the leading coefficients of the polynomial. So a in our problem would be 3, and b in this problem would be 1. So 3 over 1 equals 3. So our horizontal asymptote is y equals 3. All right, let's try another one. Let's look at number 5. So first you want to see if this can be factored, and it can. That's a difference of squares, but they have no common factors. So there's nothing to cross out. So we can proceed as normal. So my vertical are my zeros of the denominator, and I already have it factored here. Oops, that should be minus. And then we can see that x is equal to -1 and x is equal to +1. So this problem has two vertical asymptotes, one at x equals -1 and the other at x equals 1. All right, let's talk about horizontal. So I'm going to look at my degrees. I have degree of 1 and degree of 2. So top is less than bottom. So that's this case up here. When n is less than m, the graph has the line y equals 0. Y equals 0 as the horizontal asymptote. All right, go ahead, pause the video, try the next two on your own. Let's check these out, see how we did. Okay, so I'm going to check for common factors. I can take out a 2x here. And then I can see that these x's are going to cross out. So that becomes x over 2 times x minus 2. So using that, we're going to find our vertical asymptote. So x minus 2 is what we're setting equal to 0. So x equals 2 is my vertical asymptote. And then horizontal, I have 2 equals 2 here. So that makes my horizontal asymptote the leading coefficients one over the other. So this would be leading coefficient of 1, leading coefficient of 2. So y equals 1/2 would be my horizontal asymptote there. And lastly, number 7, I'm going to see if I can factor this, and I can. So there it is, factored. And it does have a common factor of x plus 1, so I'm going to cancel those out, and I'm left with x squared over 2 plus x. So I'm going to take my denominator to find my vertical asymptote. X plus 2 is the denominator, equal to 0. So x equals -2 is my vertical asymptote there. And then lastly, horizontal. I have 2 is greater than 1, or 3 is greater than 2 if you want to start with the original. Either case, the top is bigger than the bottom. And we see that this one, according to our success criteria, when n is greater than m, we have no horizontal asymptotes. So none for this one. Okay, so that's vertical and horizontal. Let's take a look at slant. Our last case is the slant. So I'm going to turn this over here. So I can find, we're going to review vertical, and then we're also going to find slant asymptotes. So here's your success criteria. So in order for a problem, one of these rational functions, to have a slant asymptote, the degree of the numerator must be exactly 1 more than the degree of the denominator. So let's take a look at number 8, and we'll see that the degree of the numerator is 2, and the degree of the denominator is 1. So 2 is exactly 1 more than 1. So this qualifies for a slant asymptote. And then what we're going to do is we're going to divide the numerator by the denominator. And we have two techniques here. If it's in the form x minus k, we can use synthetic division. So this one can use synthetic division, but if not, use your long division. And then that will be your answer. And we'll look at that just in a second. But first of all, let's find the vertical. So I want to see if this can factor, and it cannot. So I don't have any common factors to worry about for my vertical. So I can just set it equal to 0, and I find that x equals 2 is my vertical asymptote. Now to find my slant, I need to use division. I need to divide the numerator by the denominator, and we're lucky enough in this case that we can use synthetic. So use the opposite here. So we're going to use positive 2 to divide, and then use your coefficients there to set it up. Bring down the 3 and start your process. Multiply, add, multiply, add. So what this is 3x plus 11 with a remainder of 13 over x minus 2. Now, when we answer these, we're going to answer as y equals mx plus b. You just ignore the remainder, okay? So your answer is y equals 3x plus 11. All right, you try 9 and 10 on your own. Go ahead, pause the video. All right, let's check these over. So for vertical, we check for common factors. This doesn't have any, so we can go ahead, set the denominator equal to 0 and solve. So x equals -3 is my vertical asymptote. And for my slant, it has 1 because the degree of the numerator is exactly 1 more than the denominator. So I can go ahead and divide. And I'm going to use synthetic division because it's the x minus k form there. Change the sign to -3. And then set it up. So x squared is -5. It doesn't have an x term, so fill in a 0, and then the constant is 4. Bring down the -5 and start the process of multiply, add, multiply, add. So our answer here is we have -5x plus 15 remainder, -41. So we're just going to write it as the y equals mx plus b. So y equals -5x plus 15 is your answer. All right, last one. Okay, so this ends up not being factorable. So to find our vertical asymptote, we can't factor it because it's not factorable. So we would have to use the quadratic formula. -b plus or minus square root of b squared minus 4ac over 2a. So you would fill that in. A is 1, b is -3, c is 4. You'd plug it in and you'd simplify. And after you'd simplify, I'm just going to skip right down to your answer. You would get 3 plus or minus square root of -7 over 2. Now, when you have the square root of a negative number, that is not a real solution. That turns into the square root of 7i, the imaginary unit. So, since there's no real zeros here, there is no vertical asymptote there. So none for the vertical asymptote. All right, so then let's go on to slant. This is not a candidate for synthetic division, so we have to use long division here. So we'll set it up as a long division problem, filling in our zeros for the missing terms, and then go ahead and divide. So 3x to the third divided by x squared is 3x. So that's the first term of my quotient. And I'll take that 3x and distribute it through here by multiplication. and then subtract. So 0 minus 12 is negative 12. 5 minus negative 9 turns to positive, so that's 14x squared. And then 3 minus 3 is 0. Bring down your plus 2. 14x squared divided by x squared is 14. So that's the next term of my quotient. Take the 14 and distribute it through to the divisor there. And subtract. And then this would be the remainder here. But remember, we're not concerned about the remainder, only the quotient there. So y equals 3x plus 14 is my slant asymptote. All right, that concludes the lesson. You are ready now to practice with your book work.